says, if a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So over there in the picture, we have our circle. I'm doing my best to make a circle here. All right, so what does a tangent mean?
And that's tangent?
Nope.
It's
A line that touches the circle how many times?
Once.
Once. Good. So let's make a tangent line at the bottom of that circle. Provide it for you. So if a tangent and a chord, what does a chord look like? Yeah. So if they intersect at a point on a circle, so that point of tangent is going to intersect with a chord. We're going to put our chord there. We'll say that it's intersecting at point A. Notice we have two angles created. Does everybody see where those two angles are created?
It's on either side.
Yeah, we have an angle here. I'm going to call that angle 1. And we have an angle here. I'm going to call that angle 2. Okay? Let's just put point B up here so we have something else to use for our name. So now, focus on angle 1. Just watch. Don't write this. Angle 1. Where is the location of the vertex for angle 1? Is it at the center of the circle or is it on the circle? It's on the circle, right? So if we switch back to what we just did last section, my vertex was on the circle. How did I go from arc to angle? You divide it by 2. You took half of that arc. Well, the same thing applies here. It just looks different. Now instead of having 2 chords as the sides of my angle, I have a chord and a tangent line. Still is going to be the same scenario, same thing happening, it's just now it looks differently. So we can say that, I'm going to write it to the side, you write it below, the measure of angle 1 is equal to 1/2 the measure of arc AB. So everybody sees arc AB, right? Shortest distance between the two. So whatever this arc is, angle 1 will be equal to half of it.
That makes sense.
Now let's throw a point C in here just so we can tell the difference between the left and the right arc. So the measure of angle 2 would be equal to what? 1/2 of what arc? Yeah, ACB. ACB. Good. All right. So let's think about this for a second. Let's make one that's really easy. This is not in your notes. Don't write this, just watch. If I would turn angle 1 into, ooh, that was a very big eraser. If I would turn angle 1 into 80 degrees, what would be this arc? This was 80. That would be 160, right? Because we would double it. We're just watching right now. How many degrees around the whole circle do I need? 360. So what's left over for the rest of the circle? 200. So if this arc over here on the left is 200, what does that angle then need to be? 100. What do you notice about angle 1 and 2? They're supplementary. They make a linear pair. They're supplementary. See how that works? Okay? All right, so let's do these two examples. Example 1. Find the measure of angle ABC. So angle ABC is here. What's the degree of its intercepted arc?
130.
130. The vertex of the angle is on the circle. So how do we go from arc to angle? Good. So we're going to take half of that. So half of 130 is what? 65 degrees. Good. Okay. Got it? All right. Example 2. Waiting for screen. Spinning wheel. There it is. All right, find the measure of arc KJL, which is highlighted here in red. So if this is my intercepted arc, what's the angle attached to it? 125.
Multiplied by 2.
Very good. So we're going to double that. So it's going to be 2 times 125, which is 250 degrees. What if, not that this problem did ask, what if it asked for the measure of arc KL? How would you find that?
180.
So you got two options. These guys are thinking, let's find this angle, which would be the supplement of 125. So 180 minus 125 is what? 45?
No, 55.
55.
360 minus 50.
So if this is 55 degrees, what would the arc then be?
110.
Doubling that, right? Or could we get to that same 110 by taking 250 and subtracting it from 360? Yeah. Okay, so either way we get you there, to that 110 degrees. All right, so here we had vertex occurring on the circle. Now we're going to put our vertex in two new locations. We had our vertex at the center. When it's at the center, that's the easiest because they're equal to each other. When your vertex is on the circle, it's half the intercepted arc. So now what's going to happen is we're going to put the vertex inside the circle. So if two chords intersect inside a circle, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. So on the circle off to the right side there, let's draw this out, see what it looks like. Circle's already provided. Two chords. Let's make it chord AB. And then intersect that with chord CD. I'm trying to make it so the vertex doesn't look like it's in the center of the circle. All right, so now I've got two chords intersecting inside. Everybody good so far? If you look within this, we have how many angles occurring? 4. But we have how many sets of vertical angles? 2. So I have angle, we'll call this angle 1, we'll call this angle 2. Because if I can know that this is a certain degree, I can get the vertical easily. And if this is something, I can get the vertical easily. Okay, so let's focus on the measure of angle 1 first. The measure of angle 1.
I would say angle has to equal 180.
That is correct, because they are a linear pair. They will have to add up to 180 degrees. But to find just the measure of angle 1, take notice to where your intercepted arc is for angle 1. So if I extend angle 1, what's the arc that's intercepted, or the interior of that? It's BD, right? If I go to the vertical of that to the other side, what arc is the intercepted arc? CA. Got that, Phil? So, when two chords intersect inside a circle, then the measure of each angle is 1/2 the sum. Sum means we're going to do what operation? We're going to be adding the measures of the arcs intercepted by the angles. So what we're going to do is I'm going to take 1/2 the sum of those two intercepted arcs. So I'm going to add whatever the degree of BD is. So the measure of arc BD plus the measure of arc CA. I'm running out of space over there. Can you see that CA? Oh, it's kind of light.
I can't see it.
CA. That was really thick.
I-
It's CA. Just write CA. Arc CA. There you go. Bright yellow. All right. So now if we wanted to focus on the measure of angle 2, that's going to be equal to 1/2 times, what are the two intercepted arcs from angle 2? Yeah. So notice angle 2 creates the intercepted arc of CB and AD. So it'd be the measure of arc CB plus the measure of arc AD. So now I got 3 locations of our vertex. Vertex in the center, equal. Vertex on the circle, double or half. Vertex inside, it's half the sum of the 2, because now you have 2 intercepted arcs created. What, Dominic?
I'm still confused as to how you got the amounts that you have.
What do you mean amounts? I don't know what you mean by amounts.
Like BD and
Well, you got to
CD.
figure out what the intercepted arc was.
Well, what is that? What's that again?
Look at angle 1.
Yeah.
Angle 1 creates what arc?
BD.
BD. Angle 1 is vertical to this angle, which creates what arc?
I get it now.
Okay. Yep. All right, so that's if our location is inside. The next theorem is what happens if it's on the outside. So if a tangent and a secant, 2 tangents or 2 secants intersect outside a circle, then the measure of the angle formed is 1/2 the difference of the intercepted arcs. So we're going to do all 3 scenarios below on those 3 circles that are provided there for you guys. So for the first scenario, first circle, a tangent and a secant, what's that going to look like? Tangent intersects how many times? Once. So let's make a tangent down here on the bottom. Secant intersects how many times? 2 times. So if a tangent and a secant intersect outside of the circle, so now the angle's vertex is outside of the circle, we have the following. Let's put some labelings to this. Let's make this top A, B, C, D.
Hold on a second.
Where are the 2 intercepted arcs now? Well, is BA in the interior? It's not. So it'd be AD and BD. Does everybody see that? So we have AD. Let me get this in a different color here. And we have BD as my 2 intercepted arcs. Does everybody see that? Okay, so what do we do with them? We take 1/2 the difference. So that means we're going to do what operation? Subtract. So let's put a number 1 in here. So the measure of angle 1, I would write this below. The measure of angle 1 is equal to 1/2 the difference of the 2 arcs. Well, you think you're going to do big minus small or small minus big?
Big minus small.
Yeah, because if we did small minus big, then we get a negative degree, which is not going to work out. So what would be the biggest arc? AD. Good. So the measure of arc AD minus the measure of arc BD. That's it. So you take 1/2 the difference of your 2 arcs. So what happens if it's 2 tangents? So in circle number 2, can I erase this? Everybody's good? Circle number 2, let's make 2 tangents. So tangent here, tangent here. 2 tangents intersect outside. So let's label A, B, C. Let's put angle 1 inside of angle 1. I'm going to add a point D just so I know the difference between the big and the small arc. Name for me the largest arc. Intercepted arc.
ADC?
ADC, right? That's what we said?
ADC.
Not ABC. B's not part of it. So we're going to take the largest arc, which is here, and subtract smallest arc. So the measure of angle 1 equals 1/2 my largest arc, so the measure of arc ADC minus, what's the smallest intercepted arc? AC, good. All right, and we'll do the last one, 2 secants. That's a lot easier to draw.
Hold on a second, I still need to write the formula.
Okay. So it's the same concept each time. It's just it's going to look differently sometimes. And you might have some extra parts given to you.
A measure of 8.
Good?
There, got it.
All right, 2 secants. Oops, come back.
We're ahead of it. We're getting ahead of ourselves.
We are. So circle. 2 secants is a lot easier to draw because it doesn't matter. It's just touching at one spot. All right, let's do some labeling. I'm going to make that point A, B, C, D, E. Angle 1's out there on the outside. Now where are your 2 intercepted arcs? Say it again. AE and BD, right, would be your 2 intercepted arcs. Which ones are you going to subtract?
AE minus BD.
Perfect. So the measure of angle 1 is equal to 1/2 the measure of arc AE minus the measure of arc BD. So, inside, add, divide by 2. Outside, subtract, divide by 2. On, divide by 2. In the center, equal. You got 4 different placements for your vertex that you need to remember. You need to remember the difference between all of them. All right, so flip on the back. Let's do these 2 examples. So my vertex, is it occurring inside or outside?
Inside.
Inside. So we're going to add or subtract?
Add.
We're going to add. What is the intercepted arc of angle X? How many degrees? 156. So X is equal to 1/2 the 156 plus, what's the other intercepted arc of the vertical? 130. So 156 plus 130 is 286. Half of that is 143. So X is equal to 143. Now just get your brains thinking for a little bit. I know this is not the problem. But what if the X was located here? How would you find that angle? I think Dominic said something about it earlier.
I did?
If this was 143 degrees, what should be true about these 2 angles? Right. So then we would just have to find the supplement of 143 to get to there. So you got to be aware of what it is you're asking for. Example 2, inside or outside? Outside, add or subtract? Subtract. What 2 intercepted arcs are you going to subtract?
178 and 76.
Good. So X is equal to 1/2 of 178 minus 76, which is 102. What's half of 102? 51. Good. All right, grab yourself a practice space. We're going to try some of these out and try to make them a little bit challenging.
It's pretty simple.